In this video, we'll do an example using the first law of thermodynamics, which, remember, is this equation at the top. It's the conservation of energy in thermodynamics. So first, PV plot. If this is a sample of 2 moles of an ideal gas, what is the change in temperature? So starting here and ending there, what is the change in temperature? Well, we know PV equals nRT. So T is PV over nR. We're looking for the change in temperature. So if we call this position 1 and this position 2, we're looking for T2 minus T1. And notice that P is constant, N is constant, R is also constant, so we can pull those out. And then we're just left with the V's, so V2 minus V1. So this is 2 pascals over N is 2 moles, R is 8.31. The units on that are joule per mole Kelvin, multiplied by V2 minus V1. V2, that's 5 minus 1, so 4 cubic meters. All right, and those are nasty. I can see that the moles cancel. The rest, kelvins, joules, pascals, and cubic meters, I'm just going to trust that those are also going to cancel out because I've used SI units everywhere. So T2 minus T1, this will be in Kelvin, so we'll get the answer in Kelvin. 0.48 Kelvin. Next question. So if this exact same thing is 2 moles of an ideal gas, what's the change in internal energy? Internal energy, we remember from before, 3/2 N kBT, which is 3/2 N RT. We can go either way. Since we're using moles here, we'll use the R version. So change in internal energy, again, since N stays the same, R stays the same, it's just based on the change in T. So substituting all of these values in and using delta T to get change in internal energy, 0.48 Kelvin goes in here for delta T. That's what we found on the previous slide. So this comes out to 12 joules. Now, how much work is done? Work on a PV plot is, remember, the area under the curve. So in this case, it's the width times the height. So 4 times 2, that's meters cubed times Pascal, gives you 8 joules. So how much work is done? 8 joules. So now putting together the last answers along with the first law of thermodynamics, which is, remember, this is what we get. So we're looking for the amount of heat that went into the gas, that would be Q. So if we rearrange that for Q, Q is the change in internal energy plus the work done. So now if we go back, change in internal energy was 12 joules, work done was 8. So the total heat that went in was 20 joules.